This lesson covers the topic of soil formation and the properties of soil. This lesson was designed by Sam Dreher as part of the National Science Foundation-supported Boat of Knowledge in the Science Classroom. Both of these soil pits are approximately 1 meter deep and located in the Ridges Land Lab at Ohio University. Make 2 observations about each pit, compare the pits, and construct a hypothesis as to what is causing the differences between these 2 pits. Take 30 seconds and share with your neighbor. Today we will be discussing the process of soil formation and the properties of soil texture. Please refer to the lab handout that describes how to conduct a field soil texture test. A sample of soil will be provided by your teacher. Additional instructions on how to conduct the soil texture test can be found in the link below. Please pause this video and conduct the soil texture test. Soil can take decades, centuries, or millennia to form, but can be destroyed in an instant. It takes a very long time for soil to develop from rock. Operating heavy machinery, such as tractors, can destroy soil structure and limit soil fertility. Parent material, the material from which soil is formed. The chemical and physical properties of the parent material influence the texture of the soil that is formed. 2 types of parent material are lava flows and glacial retreats. In both cases, these areas are devoid of soil and only contain parent material. Soil is formed from this parent material. Climate. Soil forms faster in warmer and wetter environments. Soils will develop more slowly in the tundra, upper left picture, than in the rainforest, upper right. Soils develop slower in the southwestern United States compared to the rainforest due to the lack of water. Landform. Hills and valleys affect exposure to sun, wind, and water. Steeper slopes promote runoff and erosion. Soil is deposited in the floodplains from the stream during flooding events, and soil on the top of the hill has an opportunity to develop a more deep, mature soil profile. Organisms. Animals mix and aerate the soil and add organic material and speed up decomposition. Plants add organic material and break down parent material. Mosses and plants excrete acidic compounds into the environment, which breaks down the parent material, creating soil. Bedrock is a continuous mass of solid rock that makes up the Earth's crust. Bedrock can be parent material that becomes soil. Weathering. Physical or chemical processes that break down rocks and minerals into smaller particles. Weathering breaks parent material into smaller parts, such as when freeze-thaw processes break apart rocks. Deposition. Drop off of eroded material at a new location, such as after a flood. Decomposition. Breakdown of organic material to form humus. Soil horizons. Layers of soil with different textures, with the younger, less developed, or that more similar to parent material near the bottom. The black color at the top of the soil pit is organic material that is being decomposed by organisms. Based on what we have discussed, explain your observations from the soil pits that we observed at the beginning of the class. Soil texture is determined by the content of clay, silt, and sand that is present in a soil sample. Clay is the smallest of the soil particles and is the most weathered. Silt is a medium-sized soil particle, and sand is the largest. Sand is the least weathered of all soil particles. We will now complete a worksheet to determine the soil type based on the proportion of the 3 soil particles. For example, if we had a soil that was 20% clay, 40% silt, and 40% sand, that soil would be classified as a loam.